Let's talk about the stoichiometry of solutions this time. The example here says that we want to calculate the volume of 12 molar HCl that just reacts with 15 grams of aluminum. Well, the first thing we need in any kind of stoichiometry problem is a balanced chemical equation, so let's do that first. We have aluminum, it says, reacting with hydrochloric acid, HCl. And when that reacts, if we have an element reacting with a compound, and we'll get way more into chemical reactions later in this year, but we've done this type of reaction in Chem 1. What we have here is a single replacement reaction. The aluminum and the hydrogen are going to switch places. We're going to get hydrogen by itself. We're going to get the aluminum with the chlorine. So there's our partners, but we have to remember that if it's an element, we always want to double check to see if it's diatomic or not. And since hydrogen is an element here because it's by itself, we hopefully remember that it is indeed diatomic. For our aluminum chloride, we always want to find charges for our compounds if they're ionic. Aluminum is a +3, always true. Chlorine is a -1, which means the formula for this compound is going to be AlCl3. Once we have that reaction written, we need to balance it now. And when we balance the reaction, looks like we're going to need to have, for every 2 aluminum chlorides, we're going to need 6 HCl's in order to get our 3 hydrogen molecules, or a total of 6 hydrogen atoms, and then a 2 in front of the aluminum so that we'll have 2 aluminum. So that should have everything balanced now, and we're ready to start the problem. Remember, we always attack stoichiometry problems by labeling the amounts of the substances we have first. It says that we have 15 grams of aluminum, and it says we have 12 molar HCl. Remember that when we have molarity, we always want to label molarity as moles per liter. Moles per liter. You might want to make a note about that and write it down. Whenever you label a stoichiometry problem like this, always put molarity in as moles per liter. So that's what we're going to do here. You'll just have to trust me on the fact that that makes this a whole lot easier to solve. So 12 moles per liter for our HCl, and it's wanting us to calculate the volume. And since it doesn't specify volume, we're going to go with a volume that's already in some of our conversion factors in the problem, some of the things that we've already labeled, which is liters. So we're going to say that we're looking for X liters here. So when we start the problem, and remember that another rule we do with solution stoichiometry problems, we did very similar problems when we did titration problems back in Chem 1. You might glance at those notes for a refresher. But we never want to start the problem with a value for the unknown. We're trying to find the unknown. We're always going to start the problem with a value for the known substance, which is aluminum in this case. There's only one value for aluminum in this particular problem, and it's 15 grams, so we're going to start with that. The only other thing that we can do when we are starting with mass is molar mass. So looking at the molar mass of aluminum, it's 26.98 grams of aluminum per mole. And now we're ready for our switch the substances conversion factor, our mole ratio. And if you look up here, you'll see that for every 2 aluminum moles, there are 6 moles of HCl. So we're going to need the 2 aluminum, 2 moles of aluminum on the bottom, so it will cancel the 6 moles of HCl on top. That's going to cancel grams of aluminum, cancel moles of aluminum, and we're left with moles of HCl. Now we want liters, and we know that moles of HCl is going to have to go on bottom to cancel that. And the only other value we're given that we know about hydrochloric acid, HCl, is that it is 12 moles per liter. So if we do that as our conversion factor, the 12 moles on bottom, the understood 1 liter on top, we have our final conversion factor. Moles of HCl will cancel, we'll be left with liters. And when we multiply and divide this out and round it to 2 sig figs, because of the 15 over there, we end the 12, we're going to end up with 0.14 liters of HCl. So it's basically just a regular stoichiometry problem, except we're dealing with a molarity solution, and we need to make sure when we label that we change it to moles per liter. Now, what about this next one? In this next problem, we're asked to find molarity of a solution of sodium hydroxide, and it tells us that 36.9 milliliters of the solution is required to react with 29.2 milliliters of a 0.101 molar hydrochloric acid solution. So we may be sitting here going blah, 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 too many numbers, but when you do that, just start labeling. Follow the attack methods. We're looking for the molarity of sodium hydroxide, so we're looking for X moles per liter. It tells us that we have 36.9 milliliters. Do yourself a favor. You might want to jot this down too. Always put volume values in these kinds of problems in liters. It'll make the problem so much easier to deal with. So changing milliliters to liters, we have 0.0369 liters. Rule of 3, move that decimal back 3 places. Pause it real quick and label the hydrochloric acid with the values that are shown in this problem, and make sure you label them correctly. So hopefully you did what I asked you to do. The 29.2 milliliters, you need to change to liters, like I asked you to label it. Rule of 3, 3 back to the left is 0.0292 liters for the HCl, and 0.101 moles per liter for our HCl. So there's the values that were given in the problem. And now it becomes even more important for us to think about what the value is that we're going to start with. Now, we've already established that we never start with a value from the unknown. So that's going to immediately knock out starting with the sodium hydroxide volume. Another rule you might want to jot down, and it's a rule we use when we're doing the titration problems, is that you always want to start with the simplest unit given, or the simplest unit for the value given for our known in this case. And the simplest unit is going to be our liters unit. We've got liters of HCl. Moles per liter indicates that this is going to be a conversion factor. And guys, you never want to start a problem with a conversion factor. It just makes it way more difficult to do. So we'll start it with our simplest unit for our known value, 0.0292 liters of HCl. Now, we may not know anything else about this problem, but we do know that liters of HCl have to go on the bottom. And since we have labeled this as moles per liter, it makes it easy to see that this value right here is going to be able to be used as a conversion factor in this problem. Now we need to put the understood 1 liter on bottom, the 0.101 moles of HCl on top. Now we're ready to switch substances. This one's easy to do because if you notice, this is a 1-to-1 reaction. There's 1 mole of HCl for every 1 mole of NaOH. So it doesn't change the values numerically, but it does switch the substances, so it's still an important step. We've got 1 mole of NaOH for every 1 mole of HCl. And finally, and this is what makes this a little bit more of an issue to solve for, we're so used to, in this next step, putting moles of NaOH on the bottom so that they'll cancel. But this time we don't want to. Look at what we're solving for. We're solving for X moles per liter. We want to keep those moles this time. We want them to be part of our unit in the end. So all we need to have is a liter value at the bottom, divide by liters over here in this next conversion factor, so that we'll end up with moles per liter for our sodium hydroxide. So the only other value left that we have not used is the 0.0369 liters of sodium hydroxide. And something a little different, we did it with titration, but it's been a while. We don't need any other units now. We've got our moles per liter. So all we're going to do on top is just simply put a 1. We just need to divide that by a liter value. And when we work this out to 3 sig figs, we end up with 0.0799 moles per liter. And when we report it, we want to go ahead and go back to molarity, because that's the common way to report this. 0.0799 molar NaOH.